whatever I want to believe that, ladies and gentlemen, we have, what is the word? I was done teaching this concept, I think, about a week ago. Now, the only thing that we are trying to do is to solidify the concepts. You are still making certain mistakes from the homeworks that I'm getting, but it's only because of, remember, we complete the theory part such that we can have the notes to refer to. The only thing that will assist us to excel or to do well is just us now doing what? It's just us exposing ourselves to high order questions which will come as part now of what? Of the exam questions. That's the reason why you always hear me say, at least try to do question 1 and question 2. Try to do this one and this one. Why, ladies and gentlemen? You can easily see the trend of these questions. They are not the same, however, they depict that now we do what? We actually perform better in the concept, because whichever type of question that is going there, somehow we will be developing an understanding, we will be developing a system, a structure on how to answer these particular concepts. Ladies and gentlemen, let me not waste your time and go straight to the matters of the day. This e-notes you have, I think Moteo, your mother was asking if I have sent this notes 19 pages. Yes, I did send 19 pages then, but now what we are going to do, ladies and gentlemen, until I feel that we are comfortable with momentum and impulse, I will keep on adding and adding and adding more on now what? On this very particular same set of notes. The reason for doing that is eventually at the end of it all, you have one big package of momentum and impulse. Ladies and gentlemen, this is the question that was given to you. Now, this question, ladies and gentlemen, it's very tricky. I don't want to try and be otherwise. Why was it chosen? It was chosen to emphasize 3 things, or maybe, yes, let's say 3 things. It was chosen, 1, maybe the question should be, Mr. Ditabe, when can I use an equation of an impulse? What will be the hint for me to use an equation of impulse? What will be a hint? Just
Don't you usually when there are two objects?
okay. Let's get maybe support Ratanam Pesho. When can I confidently say here I must use equations of impulse? What will be an ideal situation?
Isn't it when you have one object and
Mm.
you need to work out the change in momentum?
Thank you. But before working out anything, because working out means the examiner must have told me what to calculate and everything. But the fact that, Mr. Ditabe, I can confirm that when I have one object, maybe I must write here. Please, please, please. One object, or maybe let me write here to say if we have a unit. Unit, it means 1. So you might find that you have a block of this nature and another block. This thing, ladies and gentlemen, it might look like this is now, let's call it block 1, and let's call this one now block 2. but the fact that the other one is sitting on top of the other one, this thing we consider it as a unit. And unit, ladies and gentlemen, also represents now what? One object. Then once I have one object, it leads now to impulse or application of impulse. Very happy. Very, very, very happy. But Lwandle, when can I confidently say now I must work with conservation of linear momentum?
So I believe it's when there's two objects in an isolated system.
Two objects in an isolated system, 100%. Two objects already in an isolated system, this will mean now conservation of linear momenta, 100%. But now let's look at the diagram that is given. We have set one of two objects. Do we agree? Lesedi? The bullet and block one.
Yes, sir.
100%. We come now to this second part. What do we have there? It's also two objects. But now this is, let me maybe use a different pen here. This is now, let me call set number 2. This one here, set number 1. So it means for set number 1 or object number, the situation at number 1, it means I have two objects. So what must I use, Motevo? The fact that set number 1, I have the bullet and block number 1. What must I use? Impulse or conservation of linear momenta?
Conservation of linear momentum.
Definitely. Why? Because of having two objects. VC, if I were to work with block number 2 or set number 2, will I use impulse or conservation of linear momenta?
So is it block 2 alone?
No, block 2 it's now having a bullet inside. The bullet remains embedded in the second block.
So it would be conservation of linear momentum.
Conservation of linear momentum. Ladies and gentlemen, that is the biggest differentiator between impulse and conservation of linear momentum. Once you find that there's two objects, definitely it must be now conservation of linear momentum. However, we have two scenarios that are taking place. It means I must use now conservation of linear momentum for set number 1. What is happening at number 1? Use now the conservation of linear momentum for what is happening at set number 2. Very, very, very important, ladies and gentlemen. Very, very, very important. Now, let's read the question. The question says, a bullet of 4,2 grams is moving horizontally to the right with the velocity of that. Now I am at set 1. Allow me to do this. To say M of bullet, let me call it just BU, is equals to 3, I'm lying, it's 4,2 grams. But somebody asked me, do we use the mass in grams or in kg? Ladies and gentlemen, it must be in kg. Divided by 1000, 0,0042 kg. Furthermore, what else do I have? I have V initial of the bullet, which is just now 360 meters per second, hits the stationary block. Now we also have block 1, but block 1 we are told it is stationary, which is 0 meters per second. We are also told that the mass of M1, which is the block, M of the block is now what? 1150 grams. So divide that by 1000, it is something like 1,15. M is equals to 1,15 kg. Now what happens after that? The velocity of the block immediately after the bullet has passed. So the bullet is going to go through, but this block, ladies and gentlemen, V final of the block, it's now what? 0,55 meters per second. To the right, the bullet proceeds and strikes another stationary block with mass M, and the bullet now is embedded in the second block. Calculate the velocity of the second block after it has been embedded with now what? With in the block. Now, ladies and gentlemen, we have all the necessary information. But what are we needing here, or what are we going to need? Ladies and gentlemen, very easy. We are going to need the velocity at which V final of the bullet, because we are going to need to know the velocity at which the bullet hits block number 2. So we are going to calculate V final of the bullet. That is now the first part of the question. And because we agreed in this particular panel to say 2 objects for set 1, block 1 and the bullet, then we can use the conservation of linear momentum. Then we say, but M of bullet, V of bullet, plus M of block, V of block is equals to, are they moving together or separately? Ladies and gentlemen, they are moving separately, because the bullet goes through now what? Goes through block 1. So M of bullet, V of bullet after, plus M of block plus V of block. However, we are told that 0,0042 multiplied by 360 plus mass of the block is 1.15 multiplied by 0, that is now before, is equals to mass of the bullet 0,0042, V of the bullet, that is what we are looking for, but we are told that plus mass of 1.15 multiplied by 0,55. Ladies and gentlemen, you will do the mathematics. I have already done the mathematics. The mathematics tells me that V final of the bullet is equals to 209,41 meters per second, and this is to the right. But this is not the answer. Why is it not the answer? VC, why is this not the answer?
So is it because of the direction?
No, because the question says calculate the magnitude of the second block. So we are going to calculate for the velocity of the second block after the bullet has embedded into the block. So this is the velocity. Let me write velocity at which the bullet leaves now what? Block number 1. Let me write it down. So what does it say? Velocity at which the bullet, ladies and gentlemen, leaves block 1. Lesedi katadi. What does this tell us here in terms of the number of objects?
So when when the bullet leaves block 2,
When the bullet leaves block 1.
oh, it means that block 2 and the bullet has become one object.
Very true. So what must we do? We still have another set of 2 objects. So we are going to work now with set number 2. Why did I differentiate it? Lwandle, kindly mute your mic, please. Why did I break it down into 2 sets? Is for you to realize that we actually have 2 objects, block 1 and the bullet. However, the bullet managed to pass through block 1. So when it goes to block 2, we already have now another 2 objects. It's now the bullet as well as block number 2. So what does that mean? It means it's 2 now what? Objects again. So what must we do? Apply the conservation of linear momentum. So you can only apply the conservation of linear momentum when you have now what? 2 objects, ladies and gentlemen. Now let's write it down. The mathematics, please check me on that. But you will not be able to get to this particular stage. You will not get this right, provided you understand that when I have one object or a unit, I can use now impulse. But if I am working with 2 objects, please be on the lookout. You need to apply conservation of linear momentum. So this question was tricky only because of it looks like we have 3 objects, which is the bullet, block 1, block 2. But now, because of this question is based on momentum, what do we do, ladies and gentlemen? Very easy. We break it down into sections. Section 1, set 1, 2 objects. Section 2 or set number 2, 2 objects. Then it goes back to something that I know, something that I have seen before, which is now a conservation of linear momentum. So now what does this mean? It means this velocity at which the bullet leaves block 1, it's actually v initial of the bullet before it gets into the block number 2. So I'm not going to write the full formula. We are just going to say 153. What is 153, ladies and gentlemen? It is the mass of block 2. It was stationary, plus the mass of the bullet 0,0042 multiplied by 209,41, which will be equals to, they want now what? The velocity of the second block after the bullet has been embedded in. Motheo CDD, let's read this question. The bullet remains embedded in the second block. Are they moving together or separately?
Together, sir.
Together. Together means what? Together means they are going to have now what? The same velocity, because m of block 1 and m of block 2 combined, m of bullet plus m of block, this will be moving together with now what? With one velocity. Why one velocity? They are moving together. Embedded, ladies and gentlemen, basically in simple English, it means they are now becoming one. So we can easily say 0,0042, which is the mass of the bullet, plus the mass of the mass of the block is 153 V final. Whatever you get here, ladies and gentlemen, I am not sure of that, but I can give you the final answer to say it is equals to 0,57 meters per second. Please check me now on my mathematics there, but automatically this becomes 0 ne. Then maybe I can quickly use my calculator. I can quickly use my calculator to say 0,0042 multiplied by 209,41 is equals to that 0,87952. Remember, we don't round off during the calculation, we only round off at the final answer. Ladies and gentlemen, Bonolo Matosa, questions please.
So I don't have any questions, but I definitely understand more now.
Thank you very much, because you did attempt, and thank you very much for sending your homework. However, it means now we need to look into how to apply the correct principle. Thank you very much for that. And also your SI unit for velocity, it is incorrect. Also check that. Thank you very much for sending your attempt. Let's go now to Lwanle. You also sent your attempt. Thank you very much. However, you did not understand that we actually have two different sets, set number 1 and set number 2. So you only worked with set number 1, which made it now more confusing and more disturbing. Thank you very much for your attempt. Mr. Tumelo Ditabe, you also sent something here. Thank you very much. However, it is not correct only because now of what? Trying to calculate momentum independently, if I may say so. So when we want to use conservation, please, it must start here. You cannot say you want to calculate this before and calculate this after and then try to combine the two. No, it is not going to be right, because what we want, application of the principle. So it must now always start with this formula there. Please correct that. Please understand when and how to use these two principles. One object, impulse. Two objects, conservation of linear momenta. Lesedi Katadi, inputs please.
So I understand the work more now. So I did not understand the last question first, but now I do.
Thank you very much. Lwanlevezi.
So I understand a bit better, but I think I need to go try it by myself again just to make sure that I actually understand the principle that we were applying, because I started with the conservation and then somehow, somewhere, I just got lost.
You got lost only because you didn't treat, you wanted to use bullet block 1 and block 2 at the same time. That is the mistake that you did. Hence, I said, let me first ask a question. When can we use conservation of linear momenta? Because you tried using the conservation, yes, hence you say you started with the principle. However, you wanted to combine all three at once. Not possible. We only use conservation for two objects. Hence, what I did was, let me break it down into smaller nyana sets. Set number one, bullet block one, two objects that I can handle. Why? And apply conservation. Set number two, why? Bullet and the block. Apply now what? Conservation of momenta. So you, hence I said you attempted well, however, you did not know when and how to use the conservation of linear momenta. Ladies and gentlemen, we can only use conservation of linear momenta when we have two objects. The question might come and be funny, but eventually only two objects will be applicable. If it's impulse that you must use, you must only work with one object. I can't give you another complex cheat sheet, cheat rule. Mr. Ditabe, comments please, such that you can be able to move.
So I realized my mistakes. So I understand where I was wrong. So I'll be able to answer it correctly next time.
Thank you. The mistake was separating the law. So it must always start with the sum of momentum before is equals to the sum of the momentum after. And then you can manipulate, do everything. But at least this one mark, we know it is guaranteed. Very, very, very important. Like I said, this thing here, M bullet, V bullet, MBVB, it's not a formula, that thing. That thing, it is a case, it is a scenario. Why? Why here on set number one is it different now from set number two? Because it is based on the situation. They are moving together. They are embedded, as Muteo said. So it means now they must have now what? One velocity, because they are moving together, ladies and gentlemen. Thank you very much. Now, while I'm still on this question, I understand some of you were not here due to activities at school and everything. But believe you me, here, Ratanang, VC, and everybody else, Tumelo and myself, there's no way you can go out of class without homework. And I understand you have the homework that you are doing at school, but just one from the academy. Please, why one? Now I'm able to explain in detail the mistakes that I picked up from Luanle, the mistakes that I picked up from Bonolo, the mistakes that I picked up from Tumel. Already, it's now intensifying the lesson. It's already cleaning up those common mistakes, those common errors. So it is assisting me to better my education in bettering your education. If you do not send the homework, you are failing the system and you are failing yourself. I cannot be able to assist you if I do not know the mistakes that you are doing. Please, ladies and gentlemen. So you'll definitely get another one. And I need it tomorrow morning, 8 o'clock. Thank you. This one, very, very complex also. Ladies and gentlemen, please don't ask me where do I get these questions. Some of them I just come across. This one was very complex as well. Very, very complex. Let's move. A bullet a bullet of mass. It's all bullets now. I don't know why they're using guns here. Traveling horizontally strikes a wooden block, which is at rest. Another block again. Can I write that I have the block? Maybe something that you must also try to do. Write down your data, the information that is given. I have the block, its mass is 1 kg. And then it says the bullet emerges instantly on the opposite side. So the bullet penetrates the block and with a reduced velocity of 50. So I'm going to have a bullet here. But I am told that V final of the bullet, it is 50 meters per second because it is coming to the block, but it leaves the block now with 50. Do I have the mass of the bullet? Yes, it's 2 grams, which is just 0,002 kg. Then it says the frictional block acting on the block, or the frictional force acting on the block, is 1,96. Yes. Frictional force, or FK, is equals to 1,16. What comes to mind?
Yes, sir.
What comes to mind when you hear the word frictional force? Just frictional force. Anything that comes to mind. Or maybe the question should be, which topic in grade 11 talks about frictional force? Mr. Ditabe, help your fellow sister there. When we talk frictional force, which topic of grade 11 comes to mind?
So when I think of frictional force, I think of something that opposes the flow of motion. So the topic is it gonna be Newton's laws, because that's where we learned about forces.
Okay, let's check. Lwanle, what is your take? Assist Ratanang and Mr. Ditabe. When we talk frictional force, which topic in grade 11 can you confidently say this is the topic where I deal with frictional force?
Newton's second law, sir.
Newton's second law. Moteo, what is your take?
I also say it's Newton's second law.
Bonolo, what is your take?
Yeah, I also think it's Newton's law.
Thank you very much. Ladies and gentlemen, you're here last year. I told you to say Newton's laws are part of grade 12 content. they are going to be assessed now in March, June, September, October. They will forever be there. So Ratanang Pehlo, please, those e-notes of last year Newtons, you still need to have them currently. Why, ladies and gentlemen, I am still expecting you to be able to draw a free body diagram. I am still expecting you now to do what? To understand the questions on constant velocity. Ladies and gentlemen, we need that. So this is the data that is given for the purpose of saving time. But now it's momentum, it's combining frictional force of which is part of Newton's laws, specifically now what? Newton's second law, 0.9 meters. Ladies and gentlemen, VC, how many objects do we have here?
2 objects.
Thank you very much. So it means somewhere we are going to use conservation of linear momentum. Sharp. But before we do that, let's check. Calculate the magnitude of the initial velocity of the bullet without using energy principles. Don't worry about that. I specifically chose it because I saw it saying without using energy principles. I will teach you energy principles very soon. Now, we want that. Ladies and gentlemen, when the bullet hits Tumelo Tabe?
So,
Yes, sir.
I thought it comes to the law of conservation of linear momentum, it's only applicable in an isolated system. So I thought in an isolated system, we don't have external forces such as friction. So I'm perplexed. So how can
Yes.
we apply scenario?
Thank you very much. Now, what the examiners tried to do was to infuse concepts of Newton's laws as well as momentum. Hence, the very first definition there says Newton's law in terms of momentum. Why? Because this one is referring to F net. This one it's not relating to conservation of linear momentum. However, we are going to use conservation. Why conservation? Because the examiner, only thing, I was discussing it with a friend this morning, the only thing that they should have said is, then when the block leaves this point A to B, then the system becomes now what? Isolated. That is what they did not add here. So I was aware of that, because initially we'll say, but no one said the system is isolated. There's no friction. It actually says friction is when the object is still now what? Moving towards getting into A and B. So I can confidently say this space here, it is now an isolated system. But before it actually got into A, it was just now in that frictional force space. The force acting there was that 1,96. Hence, maybe I said it was a little bit challenging. But in a proper exam, believe you me, they will tell you something about isolated system. Happy, Mr. Ditavi?
Yes, sir. Thank you, sir.
Thank you very much. Now let's move. Ladies and gentlemen, how many forces do we have that are acting on the block for the purpose of time? Bonolo, how many forces are acting on the block? Lisedi, how many forces are acting on the block?
So I want to say one force.
Thank you. Lwandle, how many do we have?
So I'm not quite sure now if we should, because it's talking about Newton's second law, I'm guessing we're going to use it somewhere. I'm not sure if we should now also count normal force and weight, but I also agree with 1.
Moteo, how many forces do we have?
Considering that the block is on the surface, I think that there are more or less 3 forces.
Thank you very much. Ratanan Pehlo, how many do we have?
So I think we have 3 forces.
Thank you, VC.
So is it 2?
Mr. Ditabe.
So is it before or after the bullet penetrated into the box?
They say the frictional force acting on the block. How many do we have?
Oh,
1, 2, 3, 4. You can basically just choose any there. Or 5. Let's move. Ladies and gentlemen, the correct answer is 3. You have your FW, you have your FN, and then you have your frictional force acting in an opposite direction. Only 3. Now, what is Fnet? Fnet is equals to MA. But what do we usually say? We usually say Fnet is the sum of all the forces that are acting on the object for the object to start now accelerating. So how many forces are making this object to accelerate? Bonolo?
1, sir.
1. And that is now Fk is equals to Ma. Fk 1,96, which is equals to 1. We are working with the block, remember, A. Then we find that A is just 1,96 meters per second squared. Done. But now I have acceleration. Now what must I do with acceleration? Ladies and gentlemen, we go back to grade 10. Grade 10, equations of motion. You don't have to memorize this. It will be given in your formula sheet. VC, do you remember equations of motion, or was it not done because of COVID?
No, so we did do them.
Ne, yes. So VF is equals to VI plus AT, something like that. Delta Y is equals to VIT plus half AT squared, and this is X. Something like VF squared is equals to VI squared plus 2AX. I think this 3 is enough. There's another one that I don't like, so let's pause on that one. So can I calculate V final of the block? Yes. VF squared is equals to VI squared plus 2AX. I want the V final of that. I know it was 0 here. Why was it 0, ladies and gentlemen? I am told that the block, it is sitting at rest. V initial of the block is equals to 0. I must also write it here, of the block is equals to 0 plus 2 multiplied by 1.96 multiplied by 0,9. That is the reason why I was given that 0,9. When you do your mathematics, V final of the block is 0,594 meters per second. Happy. Now I have the velocity at which, when the block was hit, the bullet was hitting the block, they moved. But they moved now, Motero, did they move together or they moved separately after the bullet has penetrated the block? Did they move together or separately after the bullet has hit the block. Remember, you said that one embedded means together. Here they are not talking anything about embedded, but we still need what happened after the bullet has hit. Now what? The block. Did they move together? Did they move separately? What was happening actually? Moteo?
Sir, can you please repeat your question? I wasn't able to hear.
Okay, no problem. You can hear me now, ne?
Yes, sir.
Okay. The question is, are they moving together after the collision, or they are moving separately, the bullet and the block? The previous one you said they are embedded, they are moving together. This one, can we say they are moving together or separately?
Since it doesn't say that they move, that they are embedded, I'm going to say separately.
Okay, separately. How can you tell the bullet emerges instantly on the opposite side? So it means the bullet has actually left the block. So that is an indication that, ladies and gentlemen, they are not moving together. So the sum of initial momentum and the sum of momentum after is the mass of the bullet, v of the bullet, plus m of the block, v of the block, this is now initial, and m of the bullet, v of the bullet, plus m of the block, plus v of the block. Now what is the mass of the bullet? 0,004, I'm lying, 02 VBU is the question. Calculate the initial velocity of the bullet, plus the block was at rest. It is 1 multiplied by 0, which is just equals to mass of the bullet 0,002, and we are told that this is 50 when it leaves the block, plus now what, 0, okay, sorry, it's 1, mass of the block, 1 multiplied by 0,594, the one we calculated at the top. This one, ladies and gentlemen, will come to destroy itself, and we finally find our final answer. V of the bullet is equals to 347 meters per second. Ladies and gentlemen, I also don't know these things. Like I said, I tried doing it first time, second time, and then I said, let me share this one with a friend of mine who's also into sciences, and we eventually agreed this is the best approach and this is the correct answer. Because at times we don't have answers to these things, and we always prefer that let's not look into the answer, let's look into the question and derive the memorandum thereof. And we came up with this, and I think this is the best answer and the best approach that you can basically get. Ladies and gentlemen, it is exactly 9:18.